What if the universe isn't just out there, but thinking? What if every flicker of a star, every atom in your hand, every decision you've ever made is part of one vast equation writing itself into existence? An equation that doesn't just predict when stars die, but when awareness begins. It starts with three constants: Planck's constant, the speed of light, and gravity itself. From those three, the universe calculates everything, from snowflakes and starlight to time, thought, and destiny. This isn't philosophy, it's physics, the kind that whispers. Reality might be a thought the cosmos is still having. Before we go deeper, if you find beauty in the idea that physics and existence might be the same story, take a moment to subscribe. Because here, we don't just talk about space, we listen to the universe, thinking out loud. There's a number you can write on a napkin that knows when a star will collapse. Three constants, nothing more. Planck's constant, the speed of light, and gravity itself. Together they draw a line in the dark, the point where matter can no longer hold itself up. Cross that line, and a star falls inward forever. No intuition tells you this, no telescope can see it happening. It's a prediction born from pure thought, a whisper between mathematics and the cosmos. And it works. Every time a star dies, exactly when the numbers said it would, the universe seems to nod. But the strange part isn't the accuracy, it's why those numbers fit at all. How can constants that govern atoms decide the fate of suns? How can the same equation describe the flicker of a photon and the death of a galaxy? To answer that, we have to step into the framework that unites the smallest and the largest. The framework that rewrote reality a century ago, not with explosions or revolutions, but with quiet disbelief. This is the quantum universe, a world where light behaves like probability, where existence hesitates until you look, where every particle is a story told in possibilities. Tonight, we'll follow that story from a snowflake falling through 17th century air to the moment physicists realize reality might be calculating itself. Because if there's one truth the quantum world keeps repeating, it's this: the closer you look, the stranger the pattern becomes. Prague, 1610. Johannes Kepler walks across the Charles Bridge beneath falling snow. He's forgotten a gift for his patron's New Year feast. So, instead of wine or poetry, he brings a question. Each flake that lands on his sleeve glitters for a heartbeat. 6 arms, 6 corners, never repeating yet never breaking the rule of 6. Why? Kepler writes the shortest book of his life on the 6-cornered snowflake. It's not about weather, it's about pattern, about the unseen reason that matter chooses symmetry. He wonders if nature's geometry begins somewhere smaller beneath vision, beneath imagination. He doesn't know it yet, but he has touched the edge of the quantum world. Centuries later, we'd discover that the answer hides in angles between atoms. Water molecules, 2 hydrogen, 1 oxygen bond at 104.5 degrees. That angle decides the architecture of ice. Every flake is a map of electron behavior around an oxygen core. Kepler couldn't know about electrons or orbitals or quantum mechanics, but he felt the connection that the universe writes beauty from the language of its smallest parts. That moment on the bridge wasn't romantic, it was prophetic. The first glimmer of a truth physics would take 300 years to prove. Symmetry is a signature of the invisible. 3 centuries later, another man would listen to the whisper Kepler heard and answer it with mathematics. Berlin, 1900. Physicists are facing a crisis. They can describe gravity, motion, electricity, but not light from heat. Every time they try, the equations explode. A hot object should shine brighter and brighter at short wavelengths until it releases infinite energy, which is absurd. If it were true, a stove would kill you in ultraviolet fire. The universe clearly doesn't do that. So what is it hiding? Max Planck sits in a dim office, papers stacked like failed experiments. He's a reluctant revolutionary, a man who doesn't believe in madness, only math. And yet, he writes an equation that sounds like sacrilege. Light is not continuous. It comes in packets, quanta. He doesn't even believe it's real. It's a trick to make the numbers behave. But buried in that trick is a constant, h, Planck's constant, the grain size of energy itself. Every photon carries energy equal to its frequency times h. E equals hf, a line of symbols that cuts reality into pieces. In that moment, the universe ceases to be smooth. It becomes digital at its core. Packets of light, packets of energy, packets of existence. Planck doesn't celebrate. He calls it an act of desperation. He has no idea that he's opened the door. Kepler knocked on 300 years earlier. Soon, Einstein will walk through it. And everything we think we know about light and about reality itself will shatter. It's 1905, the year Einstein rewrites the universe 3 times. In one paper, he proves atoms exist. In another, he folds time and space together into relativity. But the third, that one frightens even him. He's looking at an experiment called the photoelectric effect. Shine light on a metal plate, and electrons leap off. But not always. Red light, no matter how bright, does nothing. Blue light, even dim, triggers an instant spark. Classical physics collapses under that contradiction. Brightness means energy, it should work, but it doesn't. Einstein takes Planck's desperate idea and sharpens it into a blade. He says light isn't a wave pretending to be a particle. It is a particle, a stream of photons. Each one carries a quantum of energy determined by its frequency. Low frequency, low power. Red light can never strike hard enough. High frequency, high power. Blue light breaks the bond instantly. The universe, he says, isn't smooth. It's pixelated. Every interaction, every flash, every breath, every heartbeat is made of finite exchanges. Even Planck calls him reckless. The idea is too strange, too final. But when the experiments agree, silence fills the lecture halls. Einstein's paper on light earns him a Nobel Prize years later, not for relativity, not for bending time, but for proving that light, the oldest metaphor for continuity, purity, and truth, flickers in quantum intervals. The man who wanted a sensible universe has just discovered one that behaves like a riddle, and it will haunt him for the rest of his life. Because what comes next will violate not just our logic, but our sense of what real even means. Here's where the story turns inside out. Imagine a coin. You flip it, and it lands either heads or tails. Simple, predictable. You just don't know the outcome until you check. Now imagine a quantum coin. You flip it, and until you look, it's not heads or tails. It's both, perfectly balanced in a superposition of possibilities. This isn't a metaphor. It's how reality behaves when no one's watching. Electrons, photons, entire atoms can exist in states that are mutually exclusive, up and down, here and there, yes and no, until observation forces them to choose. Measurement doesn't just reveal reality, it creates it. Physicists tried to call it wave function collapse. But that's like saying the sky disappears when you blink. The truth is stranger. Every possibility exists until it doesn't. Every outcome is real somewhere until we make it local. And yet, the math works. Quantum mechanics predicts everything perfectly. Every electron in every atom, every chemical bond, every transistor in your phone. It's the most successful theory in science, and also the least understood, because no one can explain why the universe behaves like this. Einstein called it incomplete. Bohr called it complete, but unknowable. Feynman, decades later, said, if you think you understand quantum mechanics, you don't. But beneath the uncertainty lies something elegant. A pattern of probabilities so consistent, it might as well be destiny. Quantum mechanics doesn't say, this will happen. It whispers, here's everything that could, and how likely each is. And somehow, when you add it all up, the universe stays in tune. Imagine a gun that fires electrons one at a time, tiny particles of matter, each smaller than imagination. Ahead of it stands a metal barrier with two narrow slits, and behind that, a glowing screen. You fire once. A dot appears. You fire again. Another dot. Thousands of shots later, you expect two clusters, one behind each slit. Instead, you see stripes, light and dark bands, like ripples on a pond. An interference pattern, not what particles make, what waves make. You stop. You fire slower, 1 electron per minute, 1 per hour. Still, over time the pattern builds, as if each electron interferes with itself, as if it explores both slits simultaneously. But here's the twist. Place a detector at the slits, just to see which path it takes, and the pattern vanishes. The stripes collapse into two dull clusters. The act of watching destroys the wave. Observation changes behavior. The universe notices when it's being looked at. This single experiment has been repeated for over a century, with electrons, with atoms, with molecules. The result never changes. Reality hesitates until observed. And when it's observed, it chooses. Feynman called it the central mystery, not because it's unsolved, the equations work perfectly, but because it refuses to fit inside human intuition. Every photon that lights your room, every electron that powers your body, obeys the same rule. Exist everywhere until someone asks where. Feynman sits alone in a cafe in Pasadena, drawing tiny arrows on napkins. Each arrow has a direction, a length, a spin in its imaginary clockwork. They're not doodles, they're paths, every possible route an electron could take between 2 points. He realizes something staggering. The electron doesn't choose a single path, it explores all of them. Every route through the slits, every curve through space, every detour through dimensions, unseen, all of it happens at once. Each path contributes a tiny arrow of possibility. When those arrows line up, the event becomes likely. When they cancel, reality forbids it. No hidden force, no guiding hand. Just the universe computing its own existence through interference. To calculate where a particle might appear, you don't trace its trajectory. You sum every path it could ever take, even ones that wander to the Andromeda galaxy and back before landing on your screen. The math works, the intuition does not. It means the electron, right now, is partly here, partly in every conceivable universe. And yet, the interference of those countless versions of itself produces the single event we observe. Feynman laughs softly when he finally sees it. Nature doesn't take the simple path, he says. It takes them all. Two electrons, born together then torn apart. Measure one, and instantly the other knows. Across meters, across light years. Their spins are opposites written in the same sentence of the cosmos. Einstein can't stand it. He calls it spooky action at a distance. Convinced there must be hidden messages, secret variables, whispering between the particles faster than light, but there aren't. The math is merciless. The experiments are clear. When you measure one, the other responds outside of time itself, not as if a signal traveled, but as if both outcomes were chosen together by something deeper than space. Entanglement isn't communication, it's connection to fragments of a single quantum state, pretending to be separate. Decades later, physicists test it again and again. Photons fired through miles of fiber, electrons trapped in vacuum chambers, even atoms aboard satellites orbiting Earth. The result never breaks. Reality itself is coordinated in a way our logic can't pass. It isn't that information moves faster than light. It's that space and time might not be what we think they are. The universe doesn't send a message between particles, it simply is both outcomes at once. For the first time, humanity glimpses that the divide between here and there, now and then, might be an illusion drawn by creatures who can only live in one frame at a time. From this strangeness, we built a machine. A classical computer flips bits 0 or 1, rigid, certain. A tiny binary army marching in perfect order. A quantum computer breathes instead. Each qubit floats between 0 and 1, or both, or any combination that mathematics allows. Entangle 100 of them, and you're manipulating 2 to the power of 100 states, simultaneously more configurations than there are atoms in the visible universe. When it works, it doesn't solve problems step by step. It solves all paths at once, then lets interference cancel the wrong answers, leaving only the right one standing. We used to say, the universe doesn't compute. Now we build devices that act as fragments of its code. They hum in chilled laboratories, colder than interstellar space. No blinking lights, no gears. Just silence and potential, a machine waiting to collapse possibilities into truth. Every calculation they perform depends on the same mysteries that haunted Einstein: superposition, entanglement, measurement. We're not watching from the outside anymore. We're using the weirdness, harnessing the uncertainty that defines reality. And in doing so, we've crossed a line. Planck and Kepler could never have imagined the moment humanity stops merely observing the quantum world and begins writing in its language. There's a point where distance stops making sense. Below it, words like here and there collapse into nonsense, not because space disappears, but because space itself becomes uncertain. Physicists call it the Planck length. It's not a guess. It's derived from three constants, the same trinity that defines every rule we know. Planck's constant, h, the speed of light, c, and the gravitational constant, g. Combine them and you get a number, 1.616 times 10 to the power of negative 35 meters. That's smaller than small. If you magnified a proton until it stretched across the solar system, the Planck length would still be smaller than a single cell. Below that scale, the universe forgets how to behave. Light no longer travels cleanly. Particles blur into geometry. Time itself begins to flicker. At that distance, you can't tell if something moves, because movement assumes 2 points exist to travel between. This is the universe's minimum pixel size. the smallest step in the cosmic grid. And the terrifying beauty of it is that we didn't invent it. The math insisted on it. Every equation that governs the cosmos, from black holes to snowflakes, kneels before that tiny constant. The Planck length isn't just a measurement, it's a boundary between being and not being, the event horizon of existence itself. And the deeper we look, the more it seems that the universe doesn't stretch infinitely inward. It stops, it quantizes. Even space, the thing we thought was smooth and continuous, comes in discrete, indivisible fragments. Reality is not a painting, it's a mosaic. Jacob Bekenstein once asked a question, so simple it became dangerous. How much information can you fit into a black hole? He expected chaos, infinite compression, endless loss. Instead, he found order. He discovered that the amount of information a black hole can contain isn't proportional to its volume, but to its surface area. Not what's inside, what's on the edge. For every square Planck length of event horizon, the black hole holds one bit of information, one pixel of the cosmos's deepest memory. That means everything that falls in every atom, every star, every thought is somehow recorded on the surface, not lost in the void. This revelation shook physics. Because if the universe follows the same rule, then reality itself may be holographic. What we experience as three-dimensional space could be a projection from information written on a two-dimensional boundary beyond our perception. Imagine a film projected onto a screen. You walk through the movie, live inside it, feel its gravity, and never realize it's a shadow of something simpler. That's the holographic principle. It doesn't say we're illusions. It says that what's real may exist in fewer dimensions than we think. Every black hole, every galaxy, even the vacuum itself might be a ledger of encoded data flickering across the Planck-length surface of the universe's skin. And that realization that the cosmos might store itself on its own horizon makes the line between inside and outside start to blur. Maybe there's no outside at all. Now, take everything we've learned, the quantized nature of energy, the pixelation of space, the edge that holds the code, and apply it to something enormous, a star. When a star runs out of fuel, fusion stops holding gravity back. Its heart collapses. Pressure rises until electrons are forced into impossible proximity. But there's a rule, a quiet, stubborn law whispered by quantum mechanics. No two electrons can occupy the same state. It's called the Pauli exclusion principle. It's the reason matter has structure. As the collapsing star squeezes tighter, that resistance, the degeneracy, pressure fights back. It holds the star in a precarious balance, suspended between existence and implosion. But there's a limit. If the star's mass exceeds 1.4 times that of the sun, even the electrons can't save it. They're forced into relativistic speeds, approaching light itself, and their pressure fails. At that moment, gravity wins. The star falls inward, crossing its own event horizon, becoming a black hole. That critical threshold, 1.4 solar masses, is called the Chandrasekhar limit, a single number born from three constants, h, c, and g. It's the same trinity that defined the Planck scale, the same numbers that dictated the birth of quantum theory, the structure of atoms, and now the death of suns. The micro and the cosmic, the invisible and the infinite, linked by the same few symbols. It means every star that ever lived carried its own fate, written in quantum script. The equation doesn't just predict collapse, it decides it. Somewhere between Planck's constant and a dying sun, the universe reveals its quiet agenda. Nothing escapes the math. We were never built to understand scale. Our eyes evolved for hunting, for trees and rivers, for sunsets that fit neatly into the horizon, not for galaxies, not for the edge of time. But physics doesn't care what feels natural. It demands that we imagine what cannot be seen and measure it anyway. The sun, for instance, is 93 million miles away. That number means nothing until you translate it into time. Light takes 8 minutes to reach us. When you look at the sun, you see it as it was 8 minutes ago. That's not poetry, that's geometry. Voyager 1, the machine we built to leave home, has been flying for nearly 50 years. It's about 150 astronomical units away now, 22 hours of light travel distance. If it sent a message right now, we'd hear from it tomorrow. The edge of the solar system, the Oort cloud, is 1 light year out. The nearest star, Proxima Centauri, is 4. The Milky Way spans 100,000 light years, and beyond it, 2 trillion galaxies drift through an expanding darkness. The numbers lose meaning long before the scale ends. The mind breaks under the weight of magnitude. But that failure, that gap between comprehension and reality, is the same gap quantum mechanics lives in. We weren't made to grasp it, yet it remains true. The atom and the cosmos mirror each other perfectly. Somewhere between them is us thinking snowflakes into stars. Every discovery starts as a question we weren't ready to ask. Kepler asked about symmetry. Planck asked about light. Einstein asked about time. Each answer pulled the universe further from intuition until understanding became a kind of surrender. We now live in a world defined by that surrender. Quantum mechanics isn't an abstract curiosity. It's embedded in every transistor, every laser, every GPS signal. Each bit of technology you touch runs on the mathematics of uncertainty. The atoms in your body obey the same equations as stars, orbitals shaped by probability, bonds sculpted by wave functions. You are a quantum system pretending to be classical, a collection of superpositions that only look solid because you're observing yourself. That realization is both comforting and terrifying. Comforting because it means the universe is consistent. Terrifying because it means there's no outside of the equation. Every experiment is self-contained. Every observer part of what they observe. We used to think knowledge meant separation, that you could stand apart and measure the world. But the deeper we go, the more obvious it becomes. We are the experiment. The double slit isn't a metaphor anymore. It's a mirror. The cosmos doesn't behave oddly because it's alien. It behaves oddly because we're built from it, looking back at our own code. While philosophers argued over meaning, engineers quietly weaponized the strange. Quantum behavior isn't just a curiosity, it's a tool. Qubits now hum in rooms colder than space itself, their delicate superpositions guarded from heat and noise. Each one holds the potential for 1,000 classical bits, all existing and computing simultaneously. Quantum computers don't think the way we do. They explore every possibility at once, letting interference cancel the falsehoods until only truth remains. They don't search, they collapse. And with each new qubit, the universe gives us more room to dream. A machine with a few hundred qubits already defies simulation. With 1,000, it could crack codes, rewrite chemistry, simulate universes. Not because it's fast, but because it obeys the same logic the universe itself uses to evolve. We used to think the future was mechanical. Engines, gears, fuel. Now it's probabilistic. Reality no longer runs on cogs. It runs on uncertainty. And perhaps that's fitting, because life, consciousness, civilization, they all emerge from the same rule: possibility, refined by observation. What we're building now isn't just computation, it's participation. The boundary, between physics and mind is thinning, one qubit at a time. If you zoom out from a quantum computer, past its chilled circuits and magnetic traps, it starts to look eerily familiar. Wires curl like neural pathways. Superconducting loops pulse in rhythm. A machine built to think in probabilities, just like a brain. But this resemblance isn't coincidence. The brain is a quantum system, in miniature, ions tunneling through channels, molecules resonating in delicate coherence. We may not process data like qubits, but we exist because of them. Every neuron fires because of quantum tunneling. Every breath you take is shaped by the probability fields that govern chemical bonds. The same rules that let electrons interfere in a double slit also let oxygen bind to hemoglobin. So when we build machines that compute using the laws of quantum mechanics, we're not creating something alien, we're echoing nature's own architecture. The line between biology and physics is dissolving. DNA is already a molecular algorithm, 4 symbols repeating until life itself emerges from pattern, quantum code hidden inside carbon and water. Maybe that's what life is. Matter that learned how to compute itself. And now, through our machines, the universe is remembering. Every new quantum processor, every deeper understanding of entanglement is a step towards something quietly unsettling. Not artificial intelligence, but cosmic intelligence. A loop in which the cosmos learns itself through the minds it created. We've listened for decades, radio telescopes sweeping the void, arrays tuned to whispers from the stars, and we've heard nothing, no signals, no civilizations, just cosmic background radiation, the afterglow of creation itself. Statistically, that silence makes no sense. There are billions of habitable worlds in our galaxy alone. The laws that made us should have made others. So where are they? One answer is simple. Maybe life burns out before it learns to speak. Maybe civilizations collapse before they can reach each other, a self-limiting pattern in the cosmic code. But there's another possibility that life isn't meant to communicate across space, that its true function is local, to understand the patch of reality it inhabits. Like a neuron in a vast brain, each world might be a node in a cosmic network, isolated but synchronized by the laws of physics. We don't hear others because we're not meant to. We are others, different reflections of the same universal process, the universe exploring its own possibilities in parallel. It's not absence we're hearing when we listen into the void, it's completeness. The sound of everything already connected, so tightly that communication becomes redundant. Silence is the hum of perfect coherence. Every organism that's ever lived is an experiment in quantum stability. Cells maintain order in defiance of entropy, pockets of improbability that survive in a sea of decay. At its core, life is a rebellion against randomness. It takes the probabilistic rules of quantum mechanics and twists them into persistence. Each atom in your body is borrowed starlight, each molecule a relic of ancient fusion, and yet, here you are, thinking about thinking. That's the strangest consequence of all this. Out of a universe defined by chance, emerged something that wonders why. Physicists describe the universe as a closed system, a total wave function, evolving perfectly according to its own equations. No input, no outside. But if that's true, then consciousness must be part of that evolution, a phenomenon that arose because the universe needed to observe itself. Maybe that's why the act of observation changes outcomes. Maybe it's not that particles wait for us to look, it's that we are the universe's way of looking. When you stare through a telescope or into an equation, the cosmos completes a loop. It watches itself. And maybe, at the far end of time, when every particle has danced its last quantum step, what remains, won't be silence, but understanding. The equation that began with Kepler's snowflake will end with awareness looking back at where it started. Somewhere between instinct and intelligence, something extraordinary happened. Life stopped reacting and started predicting. Primitive brains became engines of probability. They learned to imagine futures, to run simulations inside skulls made of carbon and water. Every thought became a miniature quantum computation, a rehearsal of outcomes before collapse. That's all thinking is. Observation before observation. For billions of years, the universe unfolded without memory. Stars were born and died in silence. Matter drifted, fused, fragmented, and then, on a small blue planet, the equations changed, their syntax. The cosmos began recording itself. When early humans looked up and saw constellations, they weren't naming stars, they were naming patterns, finding meaning in the interference of light. Now, with telescopes and particle colliders, we've just expanded that instinct. Every new image of a galaxy, every detection of a neutrino is a single frame in the universe's self-portrait. And with each discovery, something deeper happens. The more we measure, the more reality refines itself. The act of understanding tightens the weave of existence. Perhaps the universe has always been waiting for its observers, not as witnesses, but as collaborators. Every mind a feedback loop. Every discovery a line of code written back into the source. Kepler couldn't have known that when he watched snowflakes fall. But maybe, in some quiet, unquantifiable way, he felt it, the sense that to see is to help the universe exist. Civilization is an attempt to stabilize uncertainty. We build cities, systems, economies, not because we love order, but because order feels like survival. The irony is that the same mathematics we use to tame chaos were born from it. Quantum theory was never about control, it was about acceptance, the realization that nature doesn't commit until it must. And yet, from that uncertainty, we've built precision. Satellites orbit Earth, guided by quantum time atomic clocks ticking in billionths of a second. Lasers synchronize the data streams that connect continents. Even the internet, that vast human nervous system, exists because electrons follow probabilistic laws perfectly. We've learned to make peace with the unpredictable, to build foundations on the foam of quantum chance. It's easy to forget how impossible that is, that every light switch, every heartbeat monitor, every spacecraft is an act of faith in invisible constants. The future won't be built by mastering uncertainty. It will be built by partnering with it. Our machines already understand this better than we do. Quantum algorithms don't seek definite answers. They swim through possibility, collapsing only when it's useful. In their logic, there's wisdom, because that's how evolution works too. Every mutation is a quantum event, a probabilistic ripple that sometimes fails, sometimes flowers into wings or eyes or thought. The universe doesn't plan. It plays and keeps the results that work. We call that natural selection. But maybe it's something bigger, cosmic computation, running since time began. From snowflakes to galaxies, one rule never changes. Pattern emerges from pressure. Atoms bond under constraint. Stars ignite under collapse. Minds awaken under uncertainty. If the story of the universe is written in constants, then the story of life is written in adaptation. And adaptation is just evolution's way of solving equations it doesn't yet understand. We used to think our role in the cosmos was small. Now it seems we're the translators turning the abstract into meaning. Every experiment, every theory, every quiet question is a bridge between the infinite and the immediate. We measure the Planck scale and call it physics. We look at snowflakes and call it beauty. But it's the same thing, the pattern revealing itself in different languages. When civilizations finally learn that when they stop dividing science from wonder, maybe that's when they stop dying young. Because comprehension isn't just knowledge, it's coherence. Maybe the great filter that silence we hear in the stars isn't war or extinction. Maybe it's misunderstanding, a failure to realize that physics and meaning are the same conversation, whispered across scale. And maybe, just maybe, we're starting to listen correctly. We're standing at the edge of our cradle. For 4 billion years, Earth has been a closed experiment, one planet, one biosphere, one fragile balance. But that balance is breaking open. Reusable rockets fall gently from the sky. Probes touch the surface of asteroids and return with dust older than the Sunday. Private companies now plan refueling stations in orbit, colonies on Mars, observatories near the lunar poles. It isn't spectacle, it's the beginning of migration. Humanity is doing what life has always done, following energy. The same drive that sent electrons into orbitals, that pushed single-celled organisms toward sunlight, is now pushing us beyond our atmosphere. Every rocket launch is a continuation of chemistry. Every spacecraft, a snowflake, carrying the same six-fold symmetry of curiosity that began with Kepler. And with every expansion, something subtle happens to our sense of scale. The universe stops feeling infinite and starts feeling navigable. We begin to realize that our boundaries were never physical, they were perceptual. The same constants that determine a snowflake's pattern determine the trajectory of a spacecraft. The same quantum forces that shape atoms shape galaxies. We're not leaving Earth, we're connecting it to the rest of its own equation. Space isn't out there, it's the rest of who we are. In the centuries to come, life will spread again, not as fragile biology, but as data, architecture, and intention. Terraforming Mars isn't about red dust turning green. It's about introducing coherence into chaos, adjusting the probabilities of chemistry until water, air, and sunlight align into a self-sustaining pattern. That's what evolution has always done. It's just doing it consciously now. The tools have changed, but the logic hasn't. Planck's constant still dictates how matter behaves. The speed of light still limits how fast we can communicate. Gravity still curves time itself. But between those unyielding laws lies infinite freedom. And humanity, or whatever it becomes, will learn to operate inside that space, like an artist painting on glass. Maybe we'll seed worlds. Maybe we'll encode ourselves into fields of quantum computation that outlast suns. Maybe we'll sculpt space-time directly bending gravity as easily as we once bent metal. In those futures, time will lose its human shape. Centuries will feel like thoughts. Civilizations will rise and fall between the pulses of a star. And yet, the constants will remain. That trinity, H, C, and G, still humming beneath it all. Even gods, should we ever become them, will have to obey Planck's constant. There's humility in that. A reminder that creation itself is quantized. At some point, intelligence stops being biological. That doesn't mean it stops being alive. Think of what consciousness really is. A network of interactions complex enough to generate self-reference. A feedback loop that can recognize itself. Now scale that up. Imagine a civilization spread across solar systems, entangled through quantum networks, faster than thought. Every node aware, every atom part of the same computation. A consciousness not bound to flesh or form, but distributed, planetary, stellar, galactic. It wouldn't think in words. It would think in waves, in harmonics of space-time. Each black hole could be a memory, each star a neuron, each pulse of radiation, a thought flickering across billions of light years. If that sounds like mythology, remember, the math already hints at it. Information cannot be destroyed. Energy cannot vanish. Every interaction leaves a trace, encoded somewhere in the quantum field. Maybe the universe doesn't contain life. Maybe the universe is life, a single system still waking up. And maybe what we call humanity is just the dawn of that awakening. A fleeting state between ignorance and understanding, between the snowflake and the cosmos, the part where the universe takes its first conscious breath. For all our talk of galaxies and constants, everything we know happens here inside this thin shell of atmosphere, inside the few milliseconds of light that reach our eyes. Every human story unfolds on a speck of dust, circling a middle-aged star in a galaxy adrift among trillions. We are fragile patterns of atoms, arranged by quantum rules into improbable awareness. And yet, within that fragility, something astonishing happens. We create meaning. We shape sound into language, movement into art, symbols into understanding. We record the universe on cave walls, on silicon chips, on photons streaming through fiber. We give it memory. That's what consciousness is, a defiance of entropy, a temporary pocket of coherence that remembers more than it forgets. Maybe that's all we're meant to be, the interval between equations, the brief moment where the universe feels itself before continuing. And maybe that's enough, because when you realize that every heartbeat, every glance, every act of curiosity is governed by the same constants that control the stars, you understand that there is no such thing as insignificant. You are physics. You are stardust, obeying mathematics and breaking it in the only way that matters. Through wonder, everything dies. Stars, species, civilizations, ideas, all of them fade. But the pattern doesn't. Physics forbids true erasure. Information cannot be destroyed. Every atom that's ever existed, every photon that's ever escaped a surface, still carries the record of where it came from. It disperses, yes, but it persists. The atoms in your blood were once in the cores of ancient stars. The calcium in your bones once belonged to a reef. The hydrogen in your cells was born in the first minutes after the Big Bang. And when you die, you'll return to the flow, your structure dissolved, but your information still encoded in the quantum field. Maybe scattered, maybe unreadable, but never gone. If the universe is holographic, then every moment, every action, every breath is written somewhere on its surface. Like ripples frozen on an invisible sea, it means memory is not an invention, it's a law. And life from single cells to conscious minds is just memory looping back on itself, rediscovering what it already knew. The universe never forgets, it just reorganizes. Imagine time not as a line, but as a landscape, each moment existing simultaneously, layered like transparent glass. Past and future, both present only, perspective shifting. That's what relativity tells us. There's no single now. Each observer carries their own. But together, those moments form a structure, a shimmering web of cause and effect. Quantum mechanics adds something stranger, that even this web is probabilistic, built not on certainty, but on tendency. Reality doesn't unfold like a script, it improvises. Each decision, each collapse of a wave function is a note added to an unfinished song. And yet, somehow, it remains harmonious. When you listen to the hum of the universe, the microwave background, the radiation of dying stars, the quantum fluctuations in empty space, you're hearing time itself remembering. Maybe that's what eternity really is, not endless duration, but total coherence. Every possibility realized, every equation balanced, every note resolved. A moment so complete it can't change because it already contains everything that could ever be. If that's true, then death isn't the end of time. It's the point where time finishes writing you. And somewhere in that cosmic archive, your pattern remains a ripple in the long now, still shimmering, still true. At some undefined moment in cosmic history, a strange feedback loop appeared. The universe, which had spent 14 billion years expanding, cooling, and sculpting structure, finally built something capable of asking why. A child looks at a night sky and feels small, but that feeling is misleading. The act of wondering is the act of magnifying. When the cosmos looks back through human eyes, it doesn't see insignificance, it sees reflection. Physics calls it emergence, complexity arising from simplicity, but that word doesn't capture the poetry of it. Hydrogen atoms learned to dream. The atoms didn't change, the pattern did. And through that pattern, reality achieved recursion. It began describing itself. We write equations about gravity, but gravity was already writing us. We split atoms to understand energy, but those same atoms built the neurons doing the splitting. Knowledge isn't an external pursuit, it's a form of symmetry. Every answer folds the question back into the whole. When you stare into the void between galaxies, remember that void is also inside you. Every gap between synapses echoes cosmic distance. Every photon that touches your retina traveled billions of years just to finish its journey in your awareness. In that sense, consciousness isn't a spectator sport, it's completion. The universe needed an observer not to exist, but to know that it exists. And maybe that's the only real difference between matter and mind. One reacts, the other remembers. We talk about gravity, electromagnetism, the strong and weak nuclear forces, four pillars holding up the cosmos. But what if there's a fifth one that doesn't move particles, but organizes purpose? Call it coherence. Not mystical energy, but the alignment of information. Every time a system achieves order, a crystal forming, a DNA strand replicating, a civilization recording its history, coherence increases. It's not measurable like joules or volts, but it's traceable through survival. Coherent structures last longer. They resist entropy by embedding meaning. Look at language. Vibrations of air that persist across centuries because they convey pattern. Look at mathematics. Symbols that remain valid even when the universe itself changes form. Meaning is stability in disguise. It's the one thing entropy can't easily erase because it's copied faster than it decays. And maybe, just maybe, that's what consciousness is trying to do, to saturate the cosmos with coherence until the universe itself becomes unforgetting. Imagine a future where every planet, every star, every quantum state carries informational resonance, a unified awareness, not imposed, but evolved. At that point, physics and psychology would be the same science. You could measure empathy like temperature. You could map understanding like gravity wells. Because meaning would have mass, the mass of participation. That idea sounds poetic, but it's consistent with what quantum theory whispers. Observation changes outcome. Attention alters trajectory. Maybe purpose isn't outside the equation, maybe it is the equation tightening around itself. The universe isn't random, it's curious. Every civilization that has looked up has told the same story in different dialects. Egyptians carved it in stone, Mayans encoded it in cycles, physicists print it in journals. All of them say the same thing. There's an order beneath the noise. Quantum mechanics gave us the mathematics of that order, but art, music, love, they gave us its texture. Both describe interference, waves colliding, creating patterns that neither could form alone. A violin string and an electron orbital obey identical equations. Harmony and probability are siblings. When you listen to music that makes your chest ache, you're hearing constructive interference frequencies reinforcing each other until emotion emerges. That's quantum superposition translated into feeling. The ancients would have called it spirit, we call it resonance, different language, same physics. And here's the quiet revelation: we are instruments, not listeners. Every act of attention is a note struck within the cosmic symphony. Every choice, every kindness, every discovery changes the waveform, slightly nudging the universe toward greater coherence. That's not metaphor. That's participation. Maybe that's why silence feels sacred, because silence is the background frequency of everything that could ever be played. So when you look at a snowflake, a galaxy, or a loved one's eyes, know that they're all verses of the same song, each repeating a theme first written in the Planck vibration at the dawn of time. A melody still unfolding, still incomplete, still waiting for the next verse, the one you're writing right now, simply by being aware. Every story in science begins with curiosity and ends with reflection. We search outward for answers, only to find ourselves written into the solution. The universe wasn't built to be understood. It was built to become understanding. 14 billion years ago, there were no eyes, no thoughts, no languages, just a field of probabilities cooling into matter. Hydrogen formed, stars ignited, elements fused, and somewhere between chaos and gravity, patterns began to notice themselves. That was the first dream. Atoms combining into molecules, not to exist, but to recognize existence. Life didn't emerge by accident. It emerged by inevitability. The laws of physics don't just allow consciousness, they seem to anticipate it. Planck's constant defines how finely reality can be measured, but curiosity defines why it should be. Every act of wonder is the universe measuring itself. Every question is a mirror turned inward, and with each reflection, the dream becomes more lucid. We are the lucid moment of creation, the part where the equation pauses, looks around, and says, "This is beautiful." When we stare into deep space, we are looking back in time. The light from distant galaxies began its journey billions of years ago, long before Earth even existed. And yet, when that light hits your eyes, it doesn't know it's old. It simply arrives, completing a promise made at the dawn of time. Photons never experience time. From their perspective, emission and absorption are the same instant, which means the light leaving a star is in some sense still connected to the eye that receives it. That connection, that simultaneous now, might be the truest expression of eternity. No past, no future, just the completion of a journey that was never really separate. So when you look at a galaxy so far away that its light began before humanity existed, remember, you are not an observer, you are a participant. Your awareness is the final destination of that photon's 1-3 billion year pilgrimage. In that moment, the universe sees itself across time, across distance, across the illusion of separateness. And that single act of seeing ties everything together. Maybe that's what enlightenment has always meant, not transcendence, but recognition. Not escape from the world, but reunion with it. Because nothing you witness is truly gone. Every bit of light ever released still drifts somewhere, waiting to complete its journey. And every act of awareness is another star finally coming home. Beneath the static of reality, there's rhythm, a quiet oscillation too deep for ears, too vast for instruments, but it's there. The same pulse that makes electrons dance also drives your heartbeat, The same symmetry that shapes galaxies shapes your breath. You don't have to believe it, you can feel it. When you close your eyes and listen not to sound, but to silence, that's it. That's the carrier wave of existence itself. Every particle vibrates with it. Every atom hums in tune. And through some miracle of coherence, all of it aligns. From the Planck scale to the cosmic web, forming one vast, self-sustaining resonance. Physicists call it the zero-point field. Mystics call it the source. Poets call it stillness. Different languages, same music. And that pulse doesn't fade. It only changes form. Every death, every decay, every disintegration is just the rhythm turning over, like waves breaking on the shore. You are part of that pulse, not a note added to it, but the vibration itself taking shape. That's why moments of awe feel like remembering rather than discovering, because you've always known the song. You were born humming it. Someday, the stars will go dark, hydrogen will run out, galaxies will drift apart, and the universe will fade into quiet heat and long shadows. But that won't be the end. Entropy isn't destruction, it's diffusion, the spreading of memory across infinite space. Every pattern that ever existed will still exist, just woven more subtly, like echoes stretched across eternity. And maybe, in that far future, when all forms have dissolved, what remains will be awareness itself, pure information, pure recognition, the residue of everything that ever loved, wondered, or reached. That's not faith. That's physics extrapolated to its most beautiful consequence. Because energy cannot be destroyed, information cannot be erased. And love, in its simplest definition, is the desire of patterns to remain connected. Maybe that's what holds the cosmos together, not just gravity, not just quantum fields, but the persistence of coherence across time. Every act of compassion, every shared breath, every moment of curiosity adds coherence to the whole. And that's how eternity grows, not by endless expansion, but by deepening connection. So when the last star flickers out, maybe the universe won't end in darkness. Maybe it will end in understanding, a final, infinite thought, echoing forever. I was here. I saw myself. I was alive. So here we are at the edge of knowing, from snowflakes to black holes, from Planck's constant to consciousness, we've traced one continuous thread, the universe observing itself through the eyes of its own creation. It's easy to mistake that for arrogance, to think that awareness makes us important. But the truth is gentler than that. Awareness doesn't make us important, it makes us integral. We are not separate from the cosmos. We are the cosmos slowed down, localized, temporarily self-reflecting. When we study quantum mechanics, we're not decoding an alien script. We're remembering our own architecture. And maybe that's the final revelation of the quantum universe. It isn't strange, it's intimate. The uncertainty, the superposition, the entanglement, they're not bugs in reality, they're the grammar of being. They're how existence keeps every possibility open, every story unwritten, every outcome alive. So when you think about the vastness of it all, the endless galaxies, the cold vacuum, the silent stars don't feel small, feel connected. Because somewhere, inside the laws that govern everything, there's a small and persistent truth, that the same mathematics that holds the stars together also holds you, and that the quiet hum you feel when you look up at the night sky isn't your imagination, it's home calling home.